To give a short overview, we want to discuss with you today. We'll be inviting a few speakers from the different pilot sites that we have within the D2 Grids project to tell us more about 5G DHC in practice. So these are all innovative projects from within D2 Grids that have been working to bring 5G fifth generation district heating and cooling principles to life. So I'd like to go ahead and invite Ria, Frank, Hugh, Alistair, and Jonathan to come and join us up here, so that way it's a bit easier to bring you up for your presentations. I'll come to you a sec. And we'll indeed be beginning with 2 examples of 5G DHC, which involves recovering heat from abandoned mines. So starting, have Ria, the Chief Executive Officer of Mijnwater, standing to my right, and Frank Peper will come shortly to tell about the pilot in Bochum. So we'll start, as I mentioned, with you, Ria, to tell about Mijnwater system. Brunsum, the pilot in D2 Grids, is part of this, but Mijnwater is a pioneer in the technique of recovering heat from mines. So I will give the floor to you.
Okay. Thank you very much. Thank you very much for having me. I will tell you something about the new master plan that has been developed for Mijnwater. And we decided to develop this plan because Mijnwater is existing quite a while, and from the first wells have been drilled in 2007. I will show you later on. But the situation was that Mijnwater is a project that is still making losses. And our shareholders are still willing to provide us with a new capital for investments. But it will be clear that that's a situation that can't continue. So we started to develop a plan last year, from January until June, by which Mijnwater can develop further in a way that it becomes economically sustainable by not making losses anymore. First, a little bit of the history of Mijnwater. Maybe you have heard about it because Brunsum is part of this project, and in that case you have heard some more about the history of Mijnwater, I guess. But the coal mining stopped in 1974. From that time, the mine corridors, they filled with groundwater again, because when they stopped pumping away the groundwater, the corridors filled with groundwater. That groundwater is being heated by the temperature of Earth, and by that means we can gain the groundwater with certain temperatures. And the hot wells, they are at 700 meters below Earth level, and the cold wells at 200 meters. After a period of feasibility studies, the first wells were being drilled in 2005, 2007. In 2008, the first energy station was connected and started producing heat and cold. And from 2012, we started with the development of the 5th generation heating districts. And that's what Mijnwater is about today. Here we have a schedule of our system. You see at the left, you see the deep wells by which we collect temperatures of about 28 degrees Celsius. And you see the blue one, the cold wells, where we gain temperatures of about 16 degrees. By a separated backbone, this water is going into the network just after the cluster installation, which you see in the middle of the scheme. And the water of the mines is not going further than that. In the cluster installation, there's a hydraulic separation of the water. And after the cluster installation, there is demineralized water in the network. That water goes to the building that has to be heated or cooled. And just at that point, we raise or lower the temperature. And that's one of the reasons why the Mijnwater network is a very energy efficient network, because we don't have loss of temperature during transport, because we don't add temperature. We do that at a place where we have to deliver the heat. Something about the strategy that we developed for the master plan. Our goal is to deliver in a sustainable way heat and cold for the people that live in the area of Heerlen, and that's being called Parkstad. It's about 5-6 municipalities. And the start of it is a sustainable reuse of the mines. And about the mines, there is quite a negative feelings about that, and mainly about ending the coal mining, because after that, since then, we have quite a huge social economic problems in the area. A high rate of unemployability, a high rate of low incomes, and the jobs that came back after closing the mines didn't fit to the experience and the education of the people that worked in the mines. So there is still a lot of social economic problems. And in that time, one of the employees of the municipality of Heerlen, a woman, she is the founding mother of Mijnwater, she said, well, what can we do with the mines? We use them in another way so that people in our area can be proud of the mines again, and instead of having all these negative sentiments about it. And she developed the thought of gaining the heat and the cold from the mines to cool and to heat the buildings in the area. What is a very important part of our strategy is that we said that the tariffs by which we deliver heat and cold must be affordable, because there are a lot of people with low incomes in the area. And we said, well, we have to look in a way that the amount of the level of the cost that we have to make to produce the heat and cold must meet the tariffs that people are able to pay. We also said it's very important that our delivery is reliable, because if people are disconnected from the gas grid, it means that delivering heat by Mijnwater is the only way by which they can get heat, and heat is one of the basic needs. Cold also, because for the rising temperatures in summer, cold becomes even more important, but reliability is very important. So we look at redundancy in our systems and that kind of things to guarantee reliability. Then proximity is a very important part of the strategy, and that's in two ways. It is because the heat and cold is being produced and delivered in the area where people live, that's proximity, but also in the 5th generation principle, by which the heat and cold within and between buildings is being exchanged. And only when that exchanging of heat and cold is not enough to meet demands by the customers, only at that time we use the heat and the cold of the mines. And for example, during spring and during autumn, the new built buildings, they are only demanding about 30 degrees to be heated. And at that time, we don't use any heat or cold from the mines. We only use the heat and the cold which is available in the area where the building is situated. Our solution is kind to the environment in different ways. When you look at individual heat pumps, when you have a street and all the houses do have an individual heat pump, what you will see is that there is a certain level of noise, of background noise, produced by the heat pumps. It can be very annoying for people who are sensible for that. What you also see is people have their own dry coolers, that a dry cooler produces heat and blows it in the outside air. So it becomes even more warmer outside than it already is. And in all the cities we have the rising problem of heat stress, and all the individual coolers, they enlarge that problem. What Mijnwater does is we deliver cold, and the heat that's being produced by delivering cold is being captured and is or used to heat in other buildings, or it is being captured and saved in a storage in the wells in the mines, and is being used during the winter. And the last one is in the situation of Parkstad, very important, is a step-by-step transition. That is that in Parkstad you have a lot of buildings with very high energy labels, bad energy labels. And these buildings, they can be connected by Mijnwater, but they ask so much power that we have decided that the delivery of the heat and the cold that we do is maximized on 60 watt per square meter. And a building with an E, F or G label asks much more power. But we said, well, we can connect you, but then still you will have enough for about 85% of the days of the year, but you will have to keep a possibility to add heat, to produce additional heat during very cold days, and that is more than 5 days minus 5 to 10 degrees below Celsius. That doesn't happen very much anymore with the climate change, but they will have to provide that themselves, and then afterwards, when they have made their buildings more sustainable, they can get on with the Mijnwater solution completely. By that way, we make it possible for building owners that can't do all the investments in one time for making their building sustainable, to invest every year, and in the end, there will be sufficient Mijnwater. One of the things we did in the case of our master plan is that we reduced the products that we deliver. We had a huge list of products. Also quite a lot of products that were not in the core business of Mijnwater. And we said we have 3 products. Or we deliver you source temperature, and that can be the case for large utilities who have a company who maintains their building and can also maintain the energy station. Then they get 28 degrees, capped at 60 watt per square meter, and cooling around 18 degrees, and they do have to build their own heating and cooling installation and maintain and operate it. Then we have 2 other products, and they are similar, but the only difference is that at product B, that we deliver low temperature, and then it's capped on 45 degrees Celsius, and medium temperature is captured at 65 degrees Celsius. And for the other, they are the same, and in both cases, Mijnwater is going to build, to make the investment and to build the energy station, and maintains and operates the energy station. Well, in Parkstad, we talk about an area of 250 square kilometers. There live around 260,000 people. I already told a lot of buildings with very high energy labels. There was a prediction of a population decline that didn't work out. So there's no declining of population. It's a matter of stabilization, but it's not an area where there's a growth of the number of inhabitants. There are many ground-bound houses, and there is a demand for houses for young people who are starting on the property market, and there is also a need for apartments for elderly people. There is no heavy industry, but we do have quite a number of large utilities, which is important for our strategy. So here you see the steps we made by making the plan. So we standardized our product portfolio. But we also made decisions, strategic decisions on the customer groups and the area. And of the customer group, we said, well, we have to connect utilities. After that, we connect apartments, and in the third place, ground-bound houses. And the apartments and the ground-bound houses only collectively owned. So when it is property of social housing companies, or if it is a corporation of owners, private owners of buildings. The reason of that is that otherwise we should have to contract each private owner of a building. And it would take quite a long time. And for us to become, to get a sustainable economic performance of Mijnwater, it is important that the moment that in which we invest and the moment on which we connect households and utilities, must be as short, the period between has to be as short as possible. Because when we invest and we don't connect and we don't raise income, then we make losses in that period. So that's why we made that decision. And in the areas we made a choice that we are going to concentrate on Heerlen and Kerkrade in the plan period until 2030. And what you see here is that on the upper level you see Heerlen, in the middle you see Kerkrade West, and the lower part is Kerkrade Centrum. And when you look from the left to the right, you see in the left side we said, well, what do we have to build for infrastructure if we want to connect all the demand that there is in the area? And what you see on the left is the infrastructure, and after that you see the utilities and houses. But then it was still, would still be making losses. So then we optimized the variant. And then you see that some of the infrastructure and some of the buildings are faded out. So we developed a strategy by which we get the balance between the investments and the connection of the type and the number of utilities and houses by which we can make a profitable performance for Mijnwater. And in the end, it came out that we... sorry?
We have to speed up.
Yeah,
Sorry.
but it's the last slide, so I will speed up, yeah. Okay, and then we made a decision that we would develop the area of Heerlen and Kerkrade. That doesn't mean that we are not going to do anything more in the other municipalities in the area, but not in this plan period. In the meantime, when we had finished our strategy, we got a request from the municipality of Heerlen, who have a high percentage of their inhabitants have a low income. And we all know about the raised energy prices for last winter. And that means the phenomenon, in the Netherlands we call that the energy poverty. I don't know, but that's when people have to pay a too large amount of their income for the energy that they use. And they asked Mijnwater, can you do anything about that? And we developed a proposal for them by which we said, well, if you contribute one time about 8,000 euro for a household, a connection, only once, then we can connect that household to the Mijnwater system, and after that they will only have to pay about 150% less for their energy than they have to pay when they use gas. So we are now in discussion with them if they want to contribute 8,000 for a connection, then a family will be out of energy poverty for the rest of the period. So that's a way in which you can make energy transition and solving social economic problems. You can make a connection between that, and that makes the initiative even better, I guess. And it will contribute to a brighter future for the inhabitants of the area of Parkstad.
Thank you so much, Ria, for telling us about the Mijnwater system. Really wonderful, innovative system that, as you mentioned, also addresses the socioeconomic side of things. So thank you for sharing the insights on the system. Keeping in mind the time, I'd like to invite Frank Peper, the Managing Director for the project in Bochum, to also explain on your project. You can click to the slides here. We will try to keep it what briefer. But Frank, if you can tell us about the system in Bochum. I know that there was inspiration as well from the system in Heerlen. Could you tell us about how shortly how the system came to be and how it's working?
All right, I'll be more than glad to do that. Thank you very much, and bonjour, everybody. I'm very pleased to be here in Paris. It's always nice to be close to Paris. I come from the city of Bochum. Not everyone will know where it is. It's in the western part of Germany. It's 20 kilometers west from Dortmund. Dortmund is probably well known because of the very good football club. So we're close to that. And I'm managing director of FUW, which is a subsidiary of the Stadtwerke Bochum, and we are responsible for the major part of the city to operate the district heating system. And I remember my first visit in Heerlen in the Netherlands. Ria talked about it in detail. It was about 6 years ago, and we got introduced to this idea of the 5th generation district heating and cooling system. And at that time, it really thrilled me. And we decided to do a kind of similar project in the city of Bochum. I would like to talk about it shortly. But mainly, first, 5th generation. Oops, I have some. I'm sorry. Yeah, come here more. I mean, 5th generation. We will hear a bit more about the principles behind it. I'm an engineer, and one of the main principles is all of you have a refrigerator at home. Yeah? And a heat pump thermodynamically is nothing else than a refrigerator, but you're interested on the warm side, in the warm side, at the back of your fridge. And the 5th generation principle is at the end nothing more, or one main point, to try to use both sides of the heat pump, to use the warm side, but not to waste the cool side. So at the evaporator side, always something is cooled down, so why not try to use this for cooling another building? And that's one of the main principles. Okay, coming more to our project in Bochum. We also have a long mining history in the Ruhrgebiet, yeah? Coal mining, hardcore mining. We did it for 100 years. And also this area here, it's called Mark 517. This is the area where we are erecting this 5th generation project at the moment. And you see here a slight overview of this area. It's quite big. It's not as big as here in Paris-Saclay. But from left to right, it's about 1,000 meters, and from south to north, it's about 800 meters. So it's quite a big area we are developing. And you see in the eastern part of the area, there will be a lot of office buildings, a lot of university buildings, new companies working on artificial intelligence and so on. And we will all connect them to our 5th generation district heating and cooling system. There will be one very big heating cooling center, the Energy Center East. You see here as a picture in the eastern part. And there will be 2 smaller energy centers in the western part of the area. And yeah, they're all connected by this ambient loop, the Mijnwater link, because below this area was a hard coal mine. And I will talk about this now. This site underwent some transition in the last years. From 1860, really, until 1958, there was on this site a hard coal mine, a colliery, that was closed by then. And the existing mining galleries were flooded. Yeah? And that's now the treasure we drill in and try to recollect. Like Ria said, getting this mine reservoir used again, making people proud being heated by this. Yeah? And yeah, this reservoir of medium warm water we try to get to use again as ambient heat and cold source for our project, similar to the approach we see in the Netherlands. But after the coal mine was abandoned in the 1960s, you know, on this area was a big car factory by Opel, the Opel company, and approximately 20,000 people did work on this area in this huge plant. You see a picture, and some of the maybe older people in the audience might recall the Opel Kadett, which was built in Bochum, and then the Opel Astra was built in Bochum, and the Opel Zafira was built in Bochum. So for more than 50 years, these cars have been built there, and then the company, the car factory was shut down, and now the area is reshaped once again. Yeah, as I said, below this area, Mark 517 is or has been the old coal mine, hard coal mine, the mine Dannenbaum, up until the 1960s. And The principle, what we are doing there is shown here in this picture. We have already drilled one well into a depth of about minus 820 meters and tried to reach exactly one abandoned mine gallery and get some water of about 30 degrees Celsius there. And we drilled another hole into an abandoned and flooded mine gallery at a depth of about minus 340 meters. And what is going on then? If we need heat, we pump the heat from the lower level to the surface. We have heat exchangers, and then you see here this ambient heat loop. The mine water energy is transferred to the decentralized energy centers, and then we have here the heat pumps, and heat and cold is generated, and it's all supported by solar cells we will try to put on these energy centers. And if we need cold or for cooling purposes, we will more pump the colder water of about 16 degrees Celsius from the upper gallery of minus 340 meters, extract the cold, and it will be heated up in a heat exchanger, and the warmer water will be injected back in the lower reservoir. So it's a closed circle. That's very important. We don't extract mine water. It's only pumped from the one gallery to the other one. How far are we in this project? You see it here on the right. For me, that's always a very interesting schematic. You see the trajectories of our geothermal wells. And we did these wells from October 2021 to March 2022. And it was really a hard time for all of us because we had some really problems with drilling these wells. But at the end, we succeeded. And you see on the right that it was very difficult not to touch another abandoned mining gallery on the way down to minus 820 meters, because then the drilling fluid would have been lost and we would have severe problems in getting further on. Yeah? But we managed to do it, and you see the lower drilling, the GT1, is also a curved drilling. Yeah? So it needed some expertise. Okay, I got 1 more minute. Yeah, we will extract a lot of energy from this abandoned mine, as you see here. And this is already my last slide, Emilia. What we've done recently is the pumping tests. And these pumping tests were very important to test the capacity, the volumetric flow rate, which can really be extracted and injected from these two mine galleries. And you see here on the right a picture. We were very happy. We planned the whole project with an extraction and injection rate of 150 cubic meters per hour. And we could reach even more than 160 cubic meters per hour without bigger resistance. So we were quite happy about these results. And yeah, the maybe not so nice thing is that the temperature in the lower well is a bit colder than we assumed. It's just 27.6 degrees Celsius. We hope for 30, but due to the higher volumetric flow rate, this will be overcompensated. So we are quite happy now that we can extract and inject the energy we were planning. And yeah, maybe last sentence from my side is we are now very pleased and very hopeful that this project will succeed. It will take another 1 to 2 years now to erect and plan the heating cooling centers before everything gets operational. But this is all now above surface issues, yeah? And we have solved the below surface issues. And as you know, below the surface, everything is dark and you're never sure what will happen. But above surface, it's much easier. Okay, thanks a lot.
Thank you so much, Frank.